using common parts. This is 4-7 and it's problem 2. I'm condensing this into 2, 3, and 4 into this one PowerPoint. All right, so take a look at this right here. Let me get my arrow up here. This is the shape that we're going to be working with today. Now you can see that it's a little blurry, so not only is it hard to see, it's also hard to see because it's hard to see. It's overlapping. We talked about how when it's overlapping like this, kind of hard to see, and plus it's blurry, that makes it even harder. So we're going to go ahead and try to read through what is given in the picture, then we're going to redraw down here. It looks like angle ZXW is congruent. So you can see the little tiny red line down there is congruent to YWX. YWX. Okay, little red line down there. So the little angles of those triangles are congruent. The angle ZWX, the big blue lines, though, that is congruent to YXW, big blue lines over here. You know what? We just need to go ahead and draw and separate them out. So let's go ahead and do that. We're going to redraw these. There's my proof. All right, so there's my redraw of triangle ZWX. I've marked the congruent parts. Here's my triangle, my sketch of triangle YXW. I've also marked my congruent marks. Notice that these are the congruent parts and these are the congruent parts. Following the thought train, I got to write down what I'm proving. I'm proving ZW is congruent to XY. Done. This is not a triangle. These are segments. So that means they are parts of the triangle. If I am going to prove that ZW is congruent to XY, I'm going to have to prove the whole triangle is congruent. So I'm going and then say that they're corresponding parts. So the reason I'm going to use here is the corresponding parts rule. These are the parts. Corresponding parts of congruent triangles are congruent. I have referenced a triangle that is congruent. I have to go ahead and pop the triangle up here. This triangle is going to be congruent to that triangle. How can I do that? I'm noticing that I have an angle, and I know that these are common parts. So I have a side, and I have an angle. So that means that I can do this with ASA. I can prove this triangle is congruent to that one with the ASA theorem. There's ASA. I'm going to put the support letters up there so I know what to write on each line of my proof. Now on the top line, let's go ahead and fill in an angle. Angle W, I'm going to shorten it so that it's not 3 letters. I'm going to try to just shorten it to just single letters. Angle W is congruent to angle X. How do I know that? It's given in the picture, it's given in the words. I need a side, so WX is congruent to WX. It doesn't say that in the words, it doesn't say that in the picture, but I can say that it is congruent to itself by the reflexive property of congruence. All right, then I'm going to go ahead and do the last angle. Angle X over here is congruent to angle W over here, and that is given. It's given in the picture, it's given in the words. All right, there we go. We have your worksheet is going to be similar to this one. I'm going to go ahead and show you one of the more advanced ones, just so you can see what it looks like. Okay, and this one is kind of fun. So check it out. I have a triangle here with several overlapping triangles. I got this guy, this big guy, lots of triangles. So it says that CA is congruent to CE. Oh, it's isosceles, y'all. And then I have BA is congruent to DE. Oh, okay. I have some overlapping triangles, so let's figure out. I'm going to go ahead and just pop out a couple of triangles and see if that helps. So I took this triangle, I moved it down here. I took this triangle and I moved it over here. The problem with these triangles is that I am trying to prove bx is congruent to dx. Do I have an x even listed in these pictures? I do not. It's almost not helpful. Although I may actually still have a use for these triangles, so I'm going to leave them there. I'm going to pop out the other side too. Let's try this one. Now, this set of triangles has the x in it. So I should be able to prove bx is congruent to dx, or at least I hope so. All right, so I'm going to just start at the very beginning of my thought train. I'm going to pop in what I'm proving on the bottom line. Bx is congruent to dx. Okay. How would I do that? This is not a triangle. This is a part, so it's got to be that corresponding parts rule. Corresponding parts of congruent triangles are congruent, and the triangles leads me back to have to place a set of triangles here. I wouldn't place these triangles here. These triangles don't have an x in them. I need to prove these congruent, to say that these are parts of congruent triangles. It's going to have to be these triangles. So I'm going to go ahead and pop those in. Triangle ABX is congruent to triangle XDE. How can I do that? First of all, I've been told that the AB is congruent to the DE. Beyond that, the only thing I can see is that angle X would be congruent to angle X, or angle BXA would be congruent to angle DXE. That would be done by vertical angles, but just knowing this angle and this side, angle side, that's not a theorem. I need to know at least one more angle or side in order to make this work. So I may have to actually come over here and work with this set of triangles. I think I'm going to use this top proof up here to prove this set of triangles to congruent, because that might actually give me some information about one of the other sides or angles, so that I might be able to prove these guys congruent. So that's my strategy. Popping up here, going to go ahead and prove ABE is congruent to ADE. How can I do that? So first of all, AE, I know AE is congruent to itself. I also know AB is congruent to itself, and I know that DE is congruent, not to itself. AB is congruent to DE. The other thing I know is that this is an isosceles triangle. Isosceles triangles have congruent base angles. That means that angle A is congruent to angle E. So I have a side, an angle, and a side. So I think I can do this with SAS. Well, then my first side that I'm going to do is the one that's already given. AB is congruent to DE. Then I'm going to go ahead and do the angle. The angle is angle A is congruent to angle E. How do I know that? This is kind of a different reason. It's because of that isosceles rule. Base angles of isosceles triangles are congruent. Now check out this one. AE is congruent to AE. We do that with the reflexive property of congruence. So there you go. I have these. Once I say that these are congruent, then I have a little more to work with. Check this out. If these are congruent, that means that angle B is congruent to angle D, and those are corresponding parts to the other set of triangles. So that means that I now have side, angle, angle, or angle, angle, side. I have the angle, angle, side theorem. Let's do it. All right, let's use my support letters on the bottom. First angle, I'm going to start out with angle X here. Angle BXA is congruent to angle DXE. How do I know that? I know that because vertical angles are congruent. I also know that angle B is congruent to angle D. How do I know that? Because corresponding parts of congruent triangles, this is the current congruent triangles, are congruent. I also know that AB is congruent to side DE. How do I know that? It is given. Boom! You did it. All right. We have a little bit of work to do with the easier proofs that don't require multiple sets of triangles to be pulled out. You can do it. Try your best with it, and I'll be around to help.